Thank you all for joining us today. This is Leap Forward, Innovations in Nursery Automation, which is the sort of outreach arm for both digital and print for our award from the USDA National Institute of Food and Agriculture's Specialty Crops Research Initiative, award titled Labor Efficiency, Automation and Production, or LEAP Nursery Crops Toward Sustainability. We provide these every month for about 20 minutes, and we invite growers, allied industry, other academics, and independent consultants to provide ideas or ways that growers can adopt automation, show the savings, where in production the savings will occur, and perhaps provide some case studies of how it has worked. Our speaker today is Caleb Saunders, from the co-founder of Canopy, and he is going to talk about optimized irrigation with superior plant growth.
Yeah, Caleb Saunders, co-founder of Canopy. Thanks to the Leap team for having me. Thanks for spending some time, half an hour or so, or 20 minutes or so here with me today. Some of you may have been at IPPS in October of 2024 when I walked through Amy Fulcher's framework, which was 6 criteria of what an irrigation model in container production actually needs to do. That talk made the case. But today I want to pick up that thread and show you what we've built in response, what we're learning with our beta partners, and where we're headed next. Quick note to those of you here that I'm talking to before I start. Some of what I'll say will be more relevant to one group than another. To the growers, I'll talk about what changes on Monday morning. To the researchers, I'll show you what the model actually does and where I want some help validating it. And to the advisory folks, you'll see the road for that we're on, and I'll ask for your read on the shape of it. So 20 minutes, and then I'd love some questions. A quick framing. So at IPPS, I walked through Amy Fulcher's framework for what better irrigation and container production would look like. That framework is still the spine of this talk. Everything I'm going to show you, I'll score against that same 6 criteria. If you weren't at IPPS, no worries. I'll get that criteria in 2 minutes, and then we'll keep going. The shape of the next 20 minutes is the criteria first, then how Canopy is actually deciding how long to run an irrigation zone, then what we're learning with our beta partners, and then a frank read on where we stand against that criteria and where we're headed, and then Q&A at the end. So section one, the criteria, what an irrigation model for your industry has to do. And before we talk about a framework for better, it is worth being clear about what today actually looks like at most container nurseries. Folks in this room, the research and extension and know it well, but if you're newer to the industry, it might be a bigger gap than people realize. Certainly was a bit interesting to me as I've continued to dig in. Most of the operations are still running clock-based timers. They're in some capacity. They're set in the spring, maybe adjusted a few times during the season, and they don't always know whether it rained last night. Those systems don't always know, and whether yesterday was the hottest day of the year. Real intelligence sits in the head of one of you, an experienced grower or an integration manager who walks in the field and adjusts by feel, which works, but it doesn't scale and doesn't train new people. It walks out the door with that individual, and it's hard to train that again quickly. Meanwhile, the compliance picture is tightening, water restrictions in Florida, runoff regulations, Chesapeake Basin, reporting requirements, it's all going up year over year, not including cost of water when it comes to certain areas. And the cost of getting the irrigation wrong shows up everywhere, whether that's root disease, lost trees, water bills, runoff fines, and the human cost of growers spending nights worrying about a schedule that should be running itself. And that's the status quo Amy's 2012 framework was responding to, and it's the status quo for most of the industry still today. These are 6 considerations Amy Fulcher and the colleagues laid out in 2012. It's the same 6 I worked through at IPPS, and it's a really good rubric. So let me say a sentence about each one. One, physiologically grounded. The model has to actually respond to plant water use, not just run a clock. If your method can't tell why the plant needs this much water today, it's guesswork. Two, demand-based, responsive to conditions, not fixed. Model that or system that gives the same answer every day is wrong on every day except for the day the calibration occurred. Even then, without a calibration, most durations are either underwatering or overwatering. And as many of you know, most choose the delayed impact of overwatering. Three, non-invasive. The grower can't be running probes into every pot. Soil moisture sensors are great for certain crop types, but they don't survive an entire commercial nursery operation at scale. Four, easily configured to many crops. Nobody grows just one thing. A system that takes 6 weeks to set up per crop isn't going to make it past one crop. Five, it doesn't slow production. If using the model adds a step to a busy spring, growers will stop using it by March. So the workflow matters as much as the math. And lastly, six, automated. If it requires a person to babysit it, it won't survive the busy spring. System has to run on its own, and the human has to be able to override it when something's off. So I'll come back to this list near the end and walk through kind of where we stand on each of those. And before we talk about the system, what actually changes in the nursery? Because as this audience has growers in it, you care about what's different on a Monday morning. The short version, the grower runs one calibration test on a representative zone. Same pour through leaching fraction test that most of you already know. Water in, water out, calculate the percentage. One zone, one day, one number. From that point on, Canopy takes over. System pulls the local weather every day, calculates what's today's runtime should be, and executes that schedule. Nobody's pressing buttons, nobody's adjusting timers. The grower's job, really, the only ongoing job, is to rerun the calibration when something material changes. Notably, it's one of the most important jobs. But if that new substrate changes, there's a new crop stage, it's grown over the period of growing season, transition from spring to summer, rerun that pour through. Give us that new number, system re-anchors. That's it. No daily timer adjustments. No, was it going to rain? Guessing. System just runs. And that's the whole change on a Monday morning. Section two, how Canopy actually decides how long to run a zone. And this is the technical section, but I'll keep it to one equation and one worked example so it's a bit clear. Two inputs. The first is leaching fraction test. So a pour through, measure what comes out, compare it to what went in. And most of you know this measurement already. We're not asking you to learn a new one. We're asking you to give us the one that you already trust on a day where we also know the weather. That trust point matters. We had considered in some of the early prototypes giving you growers a better measurement, whether that's estimated runtimes, derived metrics. And what we learned is growers prefer a measurement that they understand to one that they don't, full stop. The only way to get the system running in your production was to anchor it to a measurement that growers already know. So that's what we did. And the second input is reference evapotranspiration. And that ET is pulled from a local weather source every day. Reference ET is well established in literature. Jeff Millian and Tom Yeager have been writing about ET-based scheduling for containers since 2010. Um, Owen and colleagues, I know Anthony, you're on one of those papers, um, did the same kind of work for leaching fraction as a scheduling tool in 2019. The point I want to land is, and this matters for the researchers in the room, is that we're not inventing inputs. We're combining inputs that have been separately validated for years. The novelty is the combination in the operational wrapper, not the underlying science. And here's the one equation that does earn a slide. Today's runtime equals the test day runtime, when you took that leaching fraction test, scaled by yesterday's ET over the test day ET. So let me read that out. Your runtime today is equal to the runtime of the test day times the fraction of the reference of ET yesterday, which is effectively what's going to be refilled from the day before, against that anchor point, that ET on the test day. So if yesterday was hotter and drier than the day you calibrated, the ratio is greater than 1. We run it longer. If it's cooler or wetter, the ratio is less than 1. We run it shorter. The model adjusts itself every day without anybody touching it. The one thing worth flagging is, and this is the most subtle point to talk about, I'll slow down a bit. We do use the same weather source for both readings. So the test day evapotranspiration or ET and yesterday's ET come from the same source. Why does that matter? Because any systemic error systematic error in the source cancels out in the ratio, meaning we don't need the weather to be absolutely accurate. We need it to be consistent. Ideally, though, we would have a local weather station in cases where that's not in place, hyperlocal, Davis or otherwise. We have the system that can run on free public data feed that gives the right answer. So let me walk through this with some real numbers because the equation is one of those things that might sound harder than and with the symbols than it is in practice. So say it's April 12th, 3 gallon viburnum in a representative zone. Grower runs the pour through. The target leaching fraction for that crop stage is 15%. The measured leaching fraction comes back at 18%. So it's close enough to target. System anchors with that adjustment. ET the day before from the local weather source is 5 millimeters. Runtime on the test day is 12 minutes. Those four numbers, crop, target LF, measured LF, and the ET become the anchor. Now it's July 24th. Same zone, same substrate, no crop changes. Notably, there will probably be quite a bit of growth, but for the sake of this example, hot and dry, ET of yesterday comes back at 7 millimeters. Ratio 7 over 5, 1.4 times. System then multiplies the original 12 by 1.4, runs the zone for 16 minutes and 48 seconds. So compared to a fixed timer that day, the plant's got an extra 4 minutes and 48 seconds, which on a hot day in Florida is the difference between healthy roots and a stressed plant. If tomorrow cools off, the ratio comes down. System runs less. That's it. And that's the whole model in production. Three design principles that fall out of the equation worth naming because they're what distinguishes this approach from a naive ET-based scheduling. One, or weather-based, purely weather-based. One is source consistency over absolute accuracy. I just covered that, but the same weather source feeds both readings. Errors cancel out. Two is a clear understanding of the crop watering needs. This is the big one. For a zone you irrigate, the math anchors back to the test day conditions, not just yesterday's weather. Because the question isn't how does yesterday's atmospheric demand compare to the day I calibrated? Well, that's a different math problem. The question is, based on known conditions, what does this plant need at this particular time in its growth cycle so I know what to do tomorrow? So the answer is right without needing lots of different data points or measurements, like canopy factor, distribution uniformity, crop coefficient. Simplifies it. And three, guardrails. Substrate has an absorption ceiling. Some crops legitimately want a lower leaching fraction. Long cadences, irrigation times can hide problems. We catch all that at the point of scheduled calculation, not at 7 a.m. when the valve is opening and running water. So it should fail early, not silent at the point in which the water is pouring out. And a quick word on the research foundation, because researchers in the room do deserve this. Amy's Fulcher is 2012 paper is the cleanest articulation of what the industry needs. We didn't write this. Amy and the team did, and every design choice that we've made, the inputs, the math, the guardrails, the cadence discipline, traces back to published work or direct grower input. I'm happy to share a full bibliography, but as you've seen probably on some of these slides already, Fulcher et al. 2012 for the criteria, Jeff Millian, Tom Yeager for 2010 onward for the ET-based scheduling and the containers, Owen, Anthony, and Fulcher 2019 for the leaching fraction, schedule and input, Hunt and McDonald for the European framing at IHC in 2014. So standing on a lot of shoulders here, which makes this possible. Now, section three, what we're learning with our beta partners. So three slides, the partnership shape and what we've heard, and ultimately the cadence that we operate at. We have one Florida deployment with another one coming online in Virginia, small footprint on purpose. And so I want to be clear about what it means and what it doesn't mean. Uh, what it means, we have one production actively running the automated approach in real zones, real crops, real schedules. And we have a weekly, if not daily, contact with the team. They tell us what's working or whether what's not working. We ship a fix. On the Virginia site, it's set up right now. It is working on a manual basis. Should be steady state in the next month or two. But what this doesn't mean is we don't have peer-reviewed quantitative water savings numbers yet. The qualitative signal is strong, The team's happy. We have very specific operational improvements we can describe, but I'm not going to give you a percentage at this stage because we don't have that data yet. And the partnership is shaped more like research than a vendor relationship. It's collaborative in nature, in motion, and worth more to us than a polished case study at this point. So these are paraphrased from the themes from grower conversations on site, the patterns that have emerged, and this is what I'd love for those of you in the research industry to focus on. It's the questions the growers ask about an automated system, and it's not the questions you'd predict from a software situation. They're more operational. Theme one, overriding, who can stop this on a Saturday? What if the irrigation manager is on vacation, system manager sees a problem, giving the control to the relevant folks to manage remotely enables that. Theme two, manual modes. How does it handle additional manual cycles? Our answer was enable the ability to configure manual zones with varying options. Again, it's an operational concern we didn't anticipate being as popular. Theme three, undo. How fast can I undo something I didn't mean to do? The growers are working under pressure, possibly in the field with wet hands, dirty hands, and may mistap something if you're doing it on your phone. We rebuilt the schedule editor twice already based on some feedback. Um, and then we're in the process of rebuilding it again. So very helpful feedback all along the way. And so what we've learned from even these three questions is more valuable than anything we thought of kind of in the process of bringing something to these folks. And that's why we keep this partner account small and the contact frequency quite high. Most important thing that helps shape how we work. We're shipping changes to the system every week. Sometimes it's a new screen, sometimes it's guardrail. We don't know that the grower needed as they hit the edge of one. And so the point isn't the speed for the sake of speed. It's not building something that doesn't get used. It's building a product that is being shaped by working nurseries in real time, not designing in isolation by some software company that's thrown over the wall. Decisions are made that we made last month are very directly related to what we would not have had on a call on a Tuesday. If you're a grower in this audience and you want input on how this thing works, that's exactly the partnership we're looking for. The path from I have a problem to it's in the product is in the order of weeks, not months, and that's a hard thing to maintain at scale. But we've made conscious choices to keep that partner count small, specifically so that we can keep that loop tight. Um, and so where do we stand against Amy's criteria? I'll walk through each one briefly. Physiological basis is strong. Reference ET is the right input for estimating crop water demand. It's defensible. It's well supported in the literature. Demand-based, strong. The system does respond daily. Hot day, it runs longer. Cooler day, it runs shorter. Non-invasive, strong. There's just no probes required in the pot. Calibration is the same pour through that growers already know about or already do. Nothing new on the bench. Nothing new buried in the substrate. Configurable to many crops, seem moderate. It's we do handle the common cases well. Daily irrigation, single manual duration, every other day cadence with manual duration. But we have edge cases, whether it's very young liners, crops with unusual root zone behavior, multi-day cycles, or excuse me, multi-cycle days that we're still tuning with our beta partners. And this is where we have real work to do and where the collaboration with researchers could help us move fast. This is low production. It's strong in the steady state, but a lot of the once the calibration is done and there's much less overhead, there's a bit of a learning curve here, and we're working to shorten that, especially for growers who maybe haven't run that standardized pour through regularly. And lastly, automated. It's very strong. It runs without someone in the loop, but allows anyone to override as needed, which we've seen as non-negotiable at this point. Section five. So where are we headed next? Caveat, this is very broad direction, rough sequencing, and where maybe field sensors might fit in. Irrigation is what got us in the door. But the same operational gaps that hurt irrigation hurt everything else at a nursery, and the data and the grower relationships are there. I think the directions that we're seeing the pull are around helping nurseries manage operations more broadly. Task management, pour through tests, planning, plant spacing, scouting, all not necessarily all on a calendar, labor scheduling, who's where, who could be elsewhere, production planning, crop tracking, knowing what's where, what stage it's in, when it'll be ready to sell, inventory management, sales alignment, what's actually in the field versus what the sales team thinks is in the field, what should every nursery have talked to its gap. The pattern is the same across all of those. The data exists, but it's in five systems or someone's head, and the cost is that that manager has to be the integration layer. Um, we see Canopy growing into that integration role because some of the data and the relationships are already in our system from the irrigation work, but we are also exploring additional in-field sensor integrations down the road, but still undetermined. I think the direction is really shaped by where the growers are telling us the help's needed. And so potentially over the next 18 months, um, again, the caveat, this is rough, not a commitment to what we're kind of where we're going right now. The sequencing depends on what these beta partners are kind of the threads they're pulling on. Now, irrigation tasks, task management plus task management. And we're already doing the irrigation, so the next natural layer is the operational tasks associated with it. For example, the pour through testing schedules. The data overlap is clear, the user is the same, case for building is becoming clear. More broadly, labor scheduling, production planning, um, really depends on those partners and their feedback. And then later sensors and irrigation. I think it really depends on is there a need? Is there a clear need? And in many cases, and some of the research has pointed out, is a solid need for or use for a solution, but there isn't a commercially available solution that exists. So depends on where the kind of beta partners go. And lastly, I know I'm running a bit over. Three doors, growers happily taking applications for the next round of partnerships. The bar's willingness to help tell us what's broken. We're quickly shifting from to looking for early adopters, want a finished product, but we need people to help shape the product. And we want to make sure this is built for those of you who you need it. Researchers actively interested in collaboration, validation of what we have, joint work, and hopefully making your life easier, knowing you have very strong bounds of what you have to maintain from a moisture point of view. And then from a vascular point of view, uh, input right now is disproportionately valuable compared to 2 years from now. So thank you, LEAP team, for hosting me, USDA and IFA for funding, um, and the beta partners, Florida, Virginia, as well as the researchers, especially Amy, Tom, Yeager, and Jeff, chief among them, whose framework everything is built on. Uh, Hand it back to you all for questions.
Thank you very much, Caleb. We appreciate it. That's very interesting. I really like the use of decades of research, both irrigation and sensors in the Southeast, and this is based on that. And it's for growers in the Southeast. You're not really going to get any stronger scientific backing plus physiological backing, and also an easier the sensor thing. We've all been working with sensors. It is that's a difficult ask in terms of getting it to be robust in production, which is what growers want. They don't want to run over anything that they've got to mess with. So I've got several questions, but I'm going to see if someone else from the audience has a question first before I ask my questions. Anybody want to ask a question? You can ask it in the chat, or you can just unmute yourself and say your question.
Hey, Anthony, I'll start. Caleb, thank you for the presentation. That was really good. Question I have is about the canopy size. And maybe I missed it somewhere in there. But that plant in April, the example you gave, would have a relatively small canopy, and it could be enormous by June or July. How does that factor into the evapotranspiration? Because it'll affect evapotranspiration. Bigger canopies transpire more water. But if you're just getting a value off the weather station, how does the canopy size factor into that?
So that's where the benefit of using the pour through method, the leaching fraction, takes the variety of inputs that you could measure and quantify, including canopy factor, and definitively says at this point in time, based on this irrigation runtime, 30 minutes, 60 minutes, whatever it may be, here's actually how much it used. And so you don't directly need to measure all of those things to get to what does that mean for my irrigation duration, because the leaching fraction gives you that answer in a very simple test.
And
That
how
makes
often do
sense.
you have to do that leaching fraction then to keep up with a crop or a group of crops? How frequently do you need to do that with this system?
Honestly, it's a grower decision. From Tom Yeager and Jeff Million's research, it's every 2 to 6 weeks during the growing season. Uh, but operationally, we've seen uh, the larger operations benefit from the ability to have a representative sample cover many greenhouses, blocks, mats. In the case where you have smaller, you would ultimately be kind of taking those individually but again, to cover that zone. So it's a bit of an it depends. But I think, and this is where the point I maybe didn't make clear, I was talking about the grower's job and all of this. It's not replacing that grower. It's enabling them to do more. And so they still would do their checks in the field to say, this plant looks a little dry. Let me run an LF test on it. And maybe it hasn't been 6 weeks yet, but it looks a little dry. The conditions have changed. It's middle of the summertime. Let's check and see where this plant is compared to where it was last time we checked.
Thank you.
So we do have a question from the field. How would this be integrated into an existing setup to make it automated? So I suspect they're talking about, let's say, for example, you have a superior controller, and that is doing sort of the calendar daily irrigations, whether or not it's raining. How would this system be integrated into this existing setup? Or if there wasn't a controller, how, like, what would be sort of the base they would be looking at?
So I think initially we set out to integrate, use whatever you have, and we kind of just do more of the brains behind the scenes to give you the right duration. The reality was most of those controllers aren't open to receiving instructions. You can't simply plug it in and say, "Hey, we're going to tell you how much to run and when to run it and how often to run it." And so that led to the necessity of building the hardware piece as well, so that we can tell that hardware what to do. I think the benefit of that outcome, while it's a bit more of an uphill battle, is that now we have a brain in the field that could talk to other sensors. So in the case where you have maybe a pressure sensor, flow meters, maybe you've got cameras that are watching the irrigation or the plants or looking for bugs or something, those opportunities become possibilities for us to consider because there's a brains out there in the field that's listening to inputs and can feed that back to kind of the brains behind the scenes or in the cloud. So, short answer is um, wouldn't directly integrate. Um, so right now we have hardware and software.
Uh, one of the challenges we have for pretty much any automation is, you know, growers have been doing it a certain way, especially when it comes to irrigation. Calendar plus their gut, and lots of experience. You address that. Um, and then when that person goes away, their type of irrigation also goes away because they have a unique and niche understanding of the substrate, the plants that they grow, the idiosyncrasies of their zones, and then their weather in that place for the last 20 years. People can't just seem to sort of step in and do. uh, what type of data, like, first of all, are you perhaps only approaching growers that might already be using some other method, say, for example, devoting an employee to leaching fraction or some other method that they're using to adjust the irrigation? And then what kind of data are you collecting to try to get them to say, if you invest in an employee to do the calibration for leaching fraction, or to at least sort of work with this, you'll be able to return it and it'll show you that it's important for you to both have the employee and this system, and you'll be better off. Those are our challenges, is to show them that intangible. There's probably not an answer. I just want to say, like, well, I think we're in the same boat. Uh, so like,
Yeah, it's a
what kind of data are you asking from them to give you, and then how are you using that to show them?
there's definitely in our case a much more natural fit if someone knows about leaching fractions, is performing them actively, because they're aware of the benefit that it yields. For those that are heard of it, used it on occasion, but not consistently, there's definitely a bit of a curve to appreciating that this investment to run this test on a, 5-minute test, 10-minute test every few weeks. Yields less shrinkage, will reduce the fungicides that you might need to spray, the uh, human bodies that need to go deal with the after effects of overwatering. And so there's definitely a bit of intangibles to your point that exist. And so our approach, at least, that we're focusing on is that word of mouth, that case study, getting a successful um, path forward with these beta partners and using that to open the next door, because there is definitely I think it was mentioned even on the last Leap presentation that, growers have a way of doing things. They've always done it that way. I think there is a transition that we're seeing with folks taking over as other generations are stepping away. And some of those generations are used to having apps that manage things. I mean, they don't have 50 years of experience in their head that they can refer to. It's, wait, you told me 20 things. I need to remember 20 things, somehow do all those 20 things, and it's not written down anywhere. How do I do this? And so enabling like the other, I think the broader problem that we're consistently seeing is the labor. And I think this was also mentioned in the last
Yeah.
presentation, which was very relevant. Labor is a problem all over. And so finding out you're not going to replace someone, you're going to repurpose them, or at least some of their time. And so how do you make them continue to focus on higher value tasks and enable some of this busy work that they could offload to having the system adjust the timer on a daily basis instead of someone driving a golf cart around and saying, move this from 10 minutes to 15 minutes, 15 minutes to 20 minutes, and then allow them to spend more time scouting uh, or fixing the other problems that can't be systemically solved. Not sure if that directly answered it, but
No, it totally does. We've been trying to get them to measure leaching fraction as a way to inform their gut. And now this, they don't actually have to make the adjustments. It'll do it for them if we can just get them to do the leaching fraction. They should be doing it anyway. And this actually capitalizes on that behavior. So I think it's a great system. I hope that uh, you work through the beta tests and get some folks in North Carolina too. Get perhaps check out Greenleaf Nursery in Tarboro would be good, a good option there. And I think also Panoramic Farm, just outside of Charlotte. I think they devote some people to doing leaching fractions also, so they're sort of already ready to use that information.
Anthony,
awesome.
Yes, you have a question?
Lorenzo has a question. He has his hand up.
Okay, I did not see that. Go ahead, Lorenzo. This is Lorenzo Catrozzi from the Pistoia region in Italy, who's going to be our speaker probably in August or September. Also works with irrigation.
Yeah, good afternoon, everybody. I'm an associate professor at the University of Pisa here in Tuscany, and I'm actually living this unique area of Pistoia. Anthony visited this area a few weeks ago, I think, which is characterized by like 5,000 hectares stuck all together of ornamental nurseries. I really enjoyed this presentation. Very nice solution. Actually, it has some connections and similarities with the startup we just co-founded here in Italy. So it was very, very interesting. I have a couple of questions for Caleb. The first one is more technical. I would like to know if the solution would fit also plants grown in the soil. And the second one is more related to the savings. I would like to know how you are measuring savings, not only water savings, but also labor and economic benefits. And related to this, also if you have an idea about how should be the pricing to be suitable for nurseries over there in US. Thank you.
So the second one was savings, third one was pricing, and the first one was what was the first one?
Will it
Oh,
work with plants grown in
field
the soil?
grown,
Yeah, yeah, yeah.
field grown, right. So the one uh, benefit to the approach from a weather-based point of view, ET is very relevant. And so the adjustment from a weather-based approach is directly relevant from what those plants are using and the kind of refill approach or concept would be applicable to field-grown crops. The difference being it's basically impossible to do the leaching fraction if well, it's a bit less relevant. So it'll be more a weather-based approach, but I think at least for us, um, partially because I grew up on a container farm, but also the seemingly underserved market of nursery farms not having solutions is what led to a more container grown focus as opposed to field grown. So all that's to say, it's the same adjustments outside of the leaching fraction would apply to more of the weather-based approach for field grown crops as opposed to leaching fraction. But because that's seemingly a bit more served, and there are some solutions that we've seen with field grown stuff, we've kind of said, well, let's hold off on field grown focus because uh, it it seems like a higher served market for now. Of course, beta partners and other folks in the field will let us know. From a savings point of view, it's very much going to depend on a nursery specific. And one of the challenges is whether a lot of numbers or data points are captured by the nursery already. You know, if they have, generally it's probably a season value that you could reference, meaning they know this season they use this much water, but they may not know on a monthly basis or weekly basis or even crop basis how much water they're using for each one of those. You can infer some of that from the static irrigation runtime. So 30 minutes at this rate equals this much water. And then we now know this is how long we ran it each day, do the math, and we can see the water savings. I think and on the labor side, it's a bit of repurposing. So again, it's a bit grower dependent for them to say we were able to reallocate folks doing more propagation, more spacing, more pesticide management, pest management, IPM. Therefore, there's a savings for us, but we don't directly know about that. There's a lot of partnership we would need from the growers and the nurseries to yield that. I think and again, the last one that we talked about at IPPS with some folks this past year was shrinkage. And so, and talking to Charlie Hall, it's one of those things that every nursery should know about. They should have their shrinkage numbers, at least roughly, even if it's not perfect number. And especially in the case of shrinkage, if it was direct related irrigation because you underwatered, that leaching fraction helps deter that because you have a definitive answer of that we know we're watering this the right amount and there's no guesswork. And so that reduces those problems at the end of the season where you are throwing stuff away that you could have sold. And then lastly, on the pricing, uh, it's in progress. I think, right now we're learning a lot. And so we're very much at the cusp of having that conversation and knowing some of kind of what that looks like. But it's still a work in progress.
Excellent. Thank you, Caleb. Thank you, everyone, for attending our session today. Let's give Caleb a round of digital applause. I think you go to the reactions, maybe, I think is, I don't know. Yeah, maybe a clap right there. Excellent. And as the kids say, hit him up, have him talk to you, visit his website, and invite him out to your nursery if he happens to be in that area just to get some more information. Thank you very much, and I'm sure we'll see you a little bit later. All right, thank you all.